Hello and welcome to this DIFI webinar. This webinar series will be discussing ways digital IF and by association DIFI is impacting the satellite industry today. First, I'd like to cover some housekeeping. If you have any questions during this webinar, please submit them via the Zoom chat. And if you at any point want to learn more about the DIFI organization, please visit our website at dificonsortium.org. Okay, let's move on to today's topic. As we all know, security, whether it be data security, network security, or even physical security, is both a critical and ever-evolving challenge. Legacy ground systems have challenges meeting the growing needs and scale of today's and future satellite systems. So today we'll discuss how digital ground-based architectures that take advantage of DIFI for interoperability can help resolve some of these challenges. So I'd like to ask the panelists to each take a minute and introduce themselves. And I'd like to start, Csaba, if you could start first introducing yourself and your company, that would be great.
Yep, thanks, Stuart. So hello, everyone. My name is Csaba Rohrer. I have background in computer engineering and data science, and I moved into product and project management. Currently, I work as a project manager in the technology and business development unit at Work Microwave. So we're really dealing with innovative emerging technologies. I've been involved in the development of our virtual ground station products. So these are our products that make use of the DIFI standard. I've also had the pleasure of organizing and being the test director for the DIFI Plugfest last year. This was hosted in our premises at Work Microwave last year. And a couple words about our company. So Work Microwave for over 35 years has been a leading developer and manufacturer of RF electronics technologies and products. We're involved in optical communications and virtual solutions as well. Thank you. Nice to meet you all.
Yeah. And Sunil?
Hey, Stuart. Thanks for the intro. Hi, my name is Sunil Gottipati. I'm the Vice President of Geo Ground Development at SES. As some of you might know, SES is one of the oldest and largest satellite services provider. We are a true multi-orbit service provider these days with our integration with Intelsat just completed. So my role specifically at SES is to develop our software-defined ground infrastructure that supports our GEO satellites to start with, but also expand towards our MEO and any NGSO partners that we work with.
Excellent, thank you. And Alvaro.
Hey everyone, I'm Alvaro Sansa. I'm the CEO of Interoperable. Apologies that I'm in a coffee area, but hopefully there is no noise. But I have been leading the company for the last 9 years, and the company has been there developing new and innovative solutions for space and satellite and defense industry for 36 years. It's a global company that we run and it has been an excellent challenge and very fun with new innovative solutions for managing signals. And that's why DIFI it's becoming more and more relevant to be able to manage them even with a greater flexibility. So I'm very excited to be here. Thank you for the invitation.
Thank you, everybody. And so we'll get started now with the questions. And so the first question, and this is open to everyone, but we'll start with Sunil. Security has always been critical in satellite networks. But what has changed in recent years that make satellite ground system security even more challenging to manage today than it used to be?
So I think one of the biggest differences we see is probably a decade ago, we were all launching, wide beam based geo satellites, and the requirement for that is pretty small. You could cover the entire globe with 3 satellites, and potentially one or two gateways per satellite, you got the whole globe covered. But the amount of throughput you could actually get through each of those links is pretty small compared to what the demand is today from our customers, right? So that kind of drove satellite operators to look at high throughput satellites and very high throughput satellites, along with the NGSO constellations that provide tremendous amounts of throughput compared to the legacy days. And with that, in mind, the ground really becomes more complicated as we start looking at these newer technologies on the satellite side. And that's driving a lot of the change in architecture and design on the ground for us.
Fantastic. Go ahead, Alvaro.
Space has become a new domain, and therefore security has been threatened significantly in multiple areas. Where electronic warfare is a factor, cyber is a factor, physical is a factor. So anything that you can do, whether it's in the ground, in the sea, or in the air, you can do now in space. And that has become a huge security concern as space assets are strategic assets for a nation. And it's very important to safeguard them. So in that regard, we need now to safeguard multiple orbits, not GEO, not MEO, not LEO, not LEO, also VLEO, are new ones that might be coming in the future. So I'm also bringing the complexity of flexible payloads, software defined, and more expensive too, as well as ground assets that are even more complex than before. Many gateways distributed, many terminals distributed that they need to roam between networks. So in that regard, there are many more places where someone can threat that security that our industry has. So we need to be ready for any challenge.
Yeah, that's great. Chaba, do you want to jump in on this?
I think Alvaro and Sunil covered this topic. I don't want to repeat them.
No, yes, no, I think you guys covered it really well. I mean, it's both a scale issue, the fact that it's a military domain issue now, it's a multi-orbit issue. I think all of that makes a ton of sense. So where do you see the biggest mismatches between the legacy architectures and the current security requirements?
I can jump in here.
That'd be great.
Yeah. So I think the biggest mismatch is that the legacy architectures assume that the security has to be implemented by physically duplicating the trusted hardware at every site, every gateway. And that model makes sense when the networks are small and more static. But as we heard just now, everything's more complex and it's changing fast, right? So today's security requirements demand more or something different. You need centralized control, consistent policy enforcement, and faster updates, more flexibility, which leads also to better auditability. So when you replicate the sites and all the equipment in them, you increase costs and complexity, but also the compliance surface as well.
Those are great points.
If I can
Go ahead,
echo
Alvaro.
what Saba mentioned, basically satellite has been very traditional industry, big pieces of hardware for many years, sometimes 30 years, doing the same thing and doing as little maintenance as possible. But one gentleman with a lot of billion of dollars have disrupted the industry, and in that regard has made us to feel pressure in the industry, and we need to react and be more agile. So having software-defined networks, having boxes that can be upgraded that can unlock new business models. So in that regard, if your customer was type A, but tomorrow needs to type B, then you can serve customer type B with a new software update and unlock that business model potentially. So whether it's a security feature, whether it is an intelligence feature, or whether it is let's say more advanced defense or any other in between. So those new black boxes, they need to be upgradable, enhanceable, and maintained. Much more critical than ever before. Before, we didn't care about much of the ground station maintenance. There were very unupdated teleports, but now they need to get updated in order to be able to compete and to be effective with their businesses and future businesses.
So, Sunil, do you have anything you want to add to this?
Well, I think Alvaro covered it nicely. I think essentially one takeaway there is the speed of response to any threat that's being detected is what's changing. The requirements for new security environments is that you have to be able to respond to them extremely fast. And in the legacy architectures, everything is hardware based, everything is custom, everything is purpose built, and to respond fastly is very hard in those environments.
No, great points. So from an operator's perspective, and Chaba touched on this, having encryption hardware co-located at every gateway, what challenges does that create for you?
So the challenges that it creates is essentially we have to deploy the specific hardware into each gateway, whether that's in different countries. Now you're going through export controls, getting all the permissions from each regime to be able to get this equipment into each teleport. Then having the right operational model to operate all of these controls, security controls, the key management, all of these things at each of those locations. That's a very, very tough challenge in terms of in a distributed environment like in the old architectures. That's where we see the biggest challenges of the distributed model.
Got it. Now, it makes perfect sense. So I'll open this up to all the panelists, but so the decentralized security, it was designed to improve resilience, but it sounds like in some ways it introduces new risks and new complexities. Is that a fair way to think about this?
So I think that it depends if it is cyber, to have a centralized brain that can orchestrate all certificates to be pushed out to the edge. It's a good way to manage, but also being able to have a safe copy of each particular certificate or firmware within those edge devices will help significantly in overcoming any cyber attack to a central location to disseminate a virus, similar to what happened in the start of the war of Ukraine with Viasat. So in that regard, we need to have a centralized brain enabled with blockchain, post-quantum encryption, and also a firmware within each individual edge device. So being able to unhack itself in case it has been compromised in any point of time, the central brain in that operation. Regarding security of the RF, we would recommend to protect each edge device that has a higher value while leaving unprotected the ones that are fully dispensable, and having all teleports well protected and scalable for any type of mission that the customer might need in a particular moment in time. So answering in regards of the cyber first and a spectrum second.
So if I'm understanding what you're saying correctly, it sounds like for a hardware-based encryption and things like that, the decentralized models sound fairly difficult to implement. But if you can virtualize and go to a software-based model, it's way more easily to be centrally controlled.
What I'm saying is a centralized is a very nice way, but not the only answer. We need a mixture, a hybrid, decentralized and centralized, having a copy under the centralized, but having a brain centralized. So it's the good of the one and the other. So it's a hybrid, a combination of both.
Excellent. Any other comments on this topic? Sunil or Chaba?
No, I think Alvaro summed it up very nicely. Having the sensitive processing in a central place while you're keeping geographic redundancy through the different sites and secure IP transport, I think that really improves resilience.
Excellent. So, Chaba, what role do you see digitizers playing at the gateway in a digital IF architecture, and why is that shift so important for security and flexibility?
That's a good question. So the digital IF architecture, the digitizers fundamentally change where the security boundary is or where it sits. So in the legacy architecture, the security boundary is the physical gateway, the site. While in the digital IF architecture, you're expanding this to the transport network and to a central processing facility. So instead of performing the full modem processing and encryption locally at the gateway, your digitizer converts the RF signal into a digital IF stream right at the antenna side. And that stream then can be transported securely over encrypted IP to a centralized processing facility. And the importance of that shift is architectural. So the gateway becomes a simpler edge node, while the sensitive hardware, modem, it could be software or hardware, sensitive modem and encryption functions move into a tightly controllable, secure environment. And this reduces the number of high trust zones that you need to certify and audit, and it allows flexibility. So it allows the operators to scale, upgrade, and reconfigure your modem and encryption system centrally without going to all the different international sites.
Fantastic. So, are there technical concerns that need to be addressed when you start thinking about moving to from an analog to a digital IF over IP type architecture?
Yes, this is the case. Actually, there are some concerns and some homework to do in this case. So because you have digital IF over IP, the network will introduce some delay. So there will be latency and jitter, and this needs to be addressed. So the architecture has to be designed in a way that your timing stays within the modem tolerances. And this is especially important for real-time services. And this also ties into determinism. So the operators, they need predictable performance. They don't just need average latency numbers, but really bounded behavior. And for that, you need proper network engineering. So there's proper network engineering strategies for this, deterministic quality of service, buffering strategies, traffic prioritization, bandwidth reservation. And you can go to extreme with dedicated fiber or other managed transport paths. Importance here is that you can back this up by service level agreement guarantees. And you also need strong encryption and authentication in the network as well. So the key point is that the digital IF works when the transport is engineered in the same details, same rigor as the RF infrastructure. So you need to include this when you're designing from the start. And yeah, this is something we have to think about.
No,
It's yeah.
Yep, that makes perfect sense. Alvaro, why is interoperability essential in this transition to digital ground, and what problems arise when digital IF implementations, are proprietary?
So we believe that as an industry, we do better together. So having companies uh, partnering, we bring a better solution to the customer. One company may be very good making chips, another company making SDRs, another company making the digitizer, another company the channelizer, and someone to process. So having each expertise and working together to provide a service, for example, that creates a value chain. That value chain is going to be richer together, and also is going to be a better opportunity to serve better the customer. And I believe that having a standard interface would help that. So, since we talked together a few years ago, we have been fan of DIFI and also on Wave for making a standard way to communicate and do not depend on certain assets that were before mandatory and summarizing um, every chain of the teleport. So we have been doing software for 36 years. So in that regard, for us, it's a way forward into having a common way of talking signals. So we see that the digital IF enable us to do things, whether it's in real time, whether it's after it happens. So, for example, we are working now for tracking our tennis mission from NASA that we have recently been awarded. And this is signals. And those signals can be done in digital IF or it can be done in RF. And that to measure very well, it's important to talk to other companies, talk to other business, and bring the expertise of each one. Because many times only one cannot do it alone. So it needs a team in an industry. And that's where we think that this environment is extremely good and we want to push for it in order to do things in a consortium manner.
Excellent, thank you. Sunil, as digital IF interoperability becomes more standard and more widely available, what makes centralizing encryption both feasible and attractive?
Yeah, so once digital IF is available and people start implementing it, the modulation and demodulation of the RF links can now move to a centralized location rather than being a function of each gateway by itself. And that actually is what helps us to move the encryption into a centralized location and the security aspects of that rather than distributed. We're moving more towards a centralized architecture. Again, to Alvaro's point earlier, I think there's going to be some regulatory requirements and things like that that we have to be accounting for. So more than likely, we will end up with a hybrid approach where you would have some functions centralized and some functions decentralized, depending on some of those requirements that we, based on some use cases that we have seen.
Yep. So how does centralizing, whether it be your encryption or other hardware, impact cost, maintenance, and security oversight?
Tremendously. I think so. In the legacy architectures where everything is based in the gateway, you're maintaining staff that understands each different technology. You need people that are skilled in understanding the modulation, demodulation techniques. They're skilled in understanding encryption and understand each hardware piece that's being deployed at these gateways. And as we move more towards a centralized environment, and we carry all of that traffic through DIFI back into a centralized location, now that centralized skill set can be located in a NOC type environment rather than at each gateway or at each teleport. So that gives us a lot of economies of scale in terms of being able to centralize those operational functions, and that helps scale faster as well for us.
Fantastic. So to Alvaro and Shaba, are there any other benefits or lessons learned that you guys would see from moving, basically centralizing, your processing or your encryption?
We see a huge advantage on centralizing, although I must admit that with DIFI we have not yet accomplished due to the bandwidth it requires for large amount of signals or teleports or infrastructure or many user beams to gather in a centralized location. Although it's being improved, but centralizing has become key, especially in multi-orbit environments as well as in very high throughput satellites where you have many beams. Those satellites only can be managed in a centralized manner. The same way as very large operators that have merged different type of fleets, being able to have a coherent way of managing has become critical, and also lowering down the knowledge required for those management is becoming more and more relevant as industries competing with the talent with other industries too, and the margins of the operators are slightly declining with this industry pressure. So in that regard, having a more centralized, more AI-driven, and more simple to the user that anybody can use has become extremely important for us in the last 5 years. Thanks to that dynamic evolution of the industry we have seen in that regard.
Excellent. So, Alvaro, so it sounds like moving from hardware-based modems to software modems and a virtualized infrastructure in general changes the way operators think about security and lifecycle management?
Yes, absolutely. So, let's say, as I mentioned, having a black box it has been a modem for a very long time, and being able to upload new type of protected waveforms, for example, we have a TTNC modem for interoperable satellites. So having that, being able to enhance over the threat, as Sunil was saying, being able to overcome the threat quickly to a time of relevance to a user, that's very important. Also, we have been working in the European protected waveform that it's software defined, as you might imagine. So being able to have and load different waveforms into a particular modem, or enable or disable or enhance those, it has become a very big need. And coming to the security, first you need to cyber protect, and then you need to build electronic countermeasures. And having those, it should improve and should not become a risk to any attack. As this way, you're able to overcome when it happens. You are resilient to it and minimize the downtime with the speed.
Excellent. So, Chaba, what do you see in shifting these critical functions to software means? Alvaro touched on it a little bit with the few, around upgrades. What do you think it really means for compliance and encryption agility in particular?
I think it has major implications, the shifting to software. So as Alvaro mentioned, the upgrades are becoming faster and less disruptive and so on. And for the compliance, it's easier to manage because you can standardize your configurations and security policies in a smaller number of controlled environments. And of course, auditing and certifications are still required, but this is now in a reduced scope, so it can improve consistency. And for encryption agility, it's also significant and it increases. So the operators can respond more quickly to a new regulatory environment and requirements, evolving threat models, or if there's updated cryptographic standards. You don't have to wait for a necessarily long hardware refresh cycle. You can do that centrally way quicker. And the key is that the software enables security to evolve continuously. Of course, it requires lifecycle management and governance to make sure that the changes are controlled and compliant.
No, thanks. That makes a lot of sense. So next question's open to everyone, but I'll start with Sunil. So does software ground infrastructure make security simpler, or does it just move the complexity to somewhere else?
I think it's a kind of a combination of both. It does make it simpler because when you're centralizing, you don't have to deal with the islands of security at each gateway. That's one area where we think it makes it simpler. I think the complexity moving elsewhere comes in as we start virtualizing environments, and we're deploying things into virtualized environments. Now you're also need to think about some of the COTS implications in terms of the virtualization infrastructure and the compute infrastructure that's out there. Typically, they're a little bit more, threat prone than custom built hardware for the satellite infrastructure. So those are areas that I think make it a little bit more complex. But every operator has an IT team that's taking care of those things today. So that environment is a well-known environment for most companies, and it's taking those processes and procedures that are implemented on the IT and the data center side and taking those and expanding those to the satellite workloads. I think is an achievable goal for us.
That's great. Csaba or Alvaro, do you want to jump in on this question?
So,
Yes.
well, go ahead. So I may go after.
Okay. So I agree. Actually, it does move some complexity elsewhere, right? And Sunil touched on this. So as I said, you need good software lifecycle management. You need to version control, take care of patch management, monitoring, and change management. But the difference is that this is software-based complexity, so it's generally more controllable. You need DevOps, but it is scalable. And distributed hardware complexity is harder to deal with, right? In the software, you can automate it, you can create CI/CD pipelines, you can standardize it and manage it centrally. But in the legacy architecture, when you have distributed, let's say, redundant hardware, you also have configuration drift. So if you have 3 secure sites that are supposed to be identical, over time they will stop being identical, right? Because perhaps different country has different regulations and you deploy a patch over there only. And over time, these can go quite large and it increases the operational burden. While with the software complexity, if you if you take, let's say, a one-time cost to set it up properly, it will not increase.
Excellent.
I
Alvaro?
would, yeah, I would like to say in a different way. Let's say that today we have satellites that have been 15, 20 years old in space, and they were designed about 25 years ago. So being able to attack them, explode, take information from them is much easier than from a new high throughput satellite that is much more advanced. So is it feasible? Yes. So one of the things that we have been doing is the test bed for European Space Agency for the Iris Square security of the payloads. So being able to have those tests on the design before they are massively manufactured, and being able to bring security from design, that's important. But again, something a product that is ongoing and enhancing over time that brings a security, in my opinion, much more security than having something in the space for 30 years, thinking that nobody is going to watch the vulnerabilities it has. We we might not, but the enemy will do 100% because that's what they are paid for. So in that regard, it's important to be able to protect ourselves, do the test ourselves, exercise ourselves, understand the vulnerabilities, and fix them before someone encounters and provide us a bigger or a smaller threat.
Yeah, so basically the fact that you're creating a dynamic baseline versus a static baseline of a hardware solution just drives much greater security. I think that's a really good point, and the points Sunil and Chaba made about scale of software are really critical things. So, how does this use case reflect a broader shift in how the satellite industry in general is designing ground segments?
So I can start. I think
That'd be great.
So from an operator perspective, there's three key things that we're looking at, right? One is digitization, the second is virtualization, and the third one is standardization. So combined between all these three, I think we're gonna get to on par with the telcos interoperability today, right? That's how we're approaching our ground environment, along with some of the actually space-based assets as well, with regenerative payloads and things like that we're looking at. The intent is to be able to be fully interoperable as a satellite network with other operators, as well as with the telcos, to the broader connectivity ecosystem. That's where our goal is. And I think DIFI is the first step in that digitization effort to be able to take advantage of the software-defined nature of the virtualization and standards compliance.
If I may, in the design phase, what we have been seeing is much more importance on audio environments, being able to bring an antenna that can do multiple frequencies, multiple orbits, having some maneuverable satellites that can overcome orbit congestion and other matters, being able to advance also the security of those particular payloads, as well as on the um, let's say on the alternative to RF, which is becoming optical. We have seen a lot more optical requirements as well, whether it's space to space, space to air, or even space to ground, and how some designs are bringing optical relay into the equation, especially for other applications that might be time sensitive. So in that regard, having that potential space really might bring a lot of applications into the equation. Also, optical many times means very large bandwidth, which to digitize bring opportunities, but also challenges in that regard in real time. But looking at enhancing that and being able to look at better networks to do not only the connection, but also other type of applications that we are seeing and users to require. That has been a big business for us. So looking at adjacent markets to satellite communication per se. And for that, digital IF is also a critical asset in order to record and playback. That's something digital IF can significantly help. So designing a lot of new applications for new type of users.
Thank you. Chaba, you have anything you want to add to this?
Just a quick sentence. So I think this shift it mirrors what happened in IT and telecom. So moving from an appliance-based infrastructure to client-side architectures, where now the functionality is decoupled from the hardware and the physical location.
Yeah, no, that is a great point that the satellite industry is not really pioneering this. They're following the steps of the bigger industries that have gone ahead of us. And we're just kind of modeling what they're doing, which I think is a great point. We're just about out of time, but I can give everybody 30 seconds if you want to any closing comments. We can start with you, Chaba, and then we'll work through. Any closing thoughts on this topic?
Yeah. So I think now for the next steps, if I could tell for any operators listening, I think they should join DIFI, of course, but also run a small pilot. Start with a ground station and create a central location somewhere and just try it out. It can coexist with the legacy architecture. So you can have the modernization can take place at the same time. It doesn't have to be in one giant leap. So yeah, this would be my recommendation.
Excellent. Sunil?
Well, I think as we are seeing much more complex satellites being built, the software-defined satellites, which we're deploying a few of them shortly, the necessity of the ground to be able to adapt to very dynamic satellite payloads is a given. And with DIFI and digitizing the RF links right at the antenna, I think it gives us a tremendous amount of flexibility to be able to process things differently than we have been doing traditionally, and encrypt things differently and take care of security in a much broader, scalable fashion.
Excellent. Thank you. And Alvaro?
I would join Sama saying, try it. You might love it. Try it with new infrastructure you need for new missions, where you don't have a spare hardware. That's a good use case to justify. Um, and digitalization and virtualization, both, that would benefit one to the other. And get comfortable, see the advantages, disadvantages, and look for a good solution that works for your particular customer and business plan, because it can scale, especially in a facility per se. It would scale and would be of use.
Oh, thank you. And so at this point, we're out of time. So I want to thank our speakers. Really appreciate you guys taking the time. It was a great webinar, and she shared some great information. And for the audience, if any of you are interested in learning more about DIFI and how you can help drive digital IF interoperability, please check out our website at the DIFIconsortium.com or .org, sorry. Just want to make a note that we work hard to keep the cost to join the organization low, but the impact you can have on the future of the satellite industry is significant through this organization. And with that, thank you all for attending.